So I'd like to just kind of report back on the discussions on the bioaccumulation testing strategy for nanomaterials discussions. And can I have the next slide, please? One of the first aspects we discussed was the need for a chemical trigger for bioaccumulation testing, you know, some sort of event that kicks off the testing strategy. And this discussion arises from the fact that the log KOW measurement, which is usually used as a trigger for bioaccumulation potential for chemicals, isn't working very well for nanomaterials, and so we need a different trigger. And the discussion was centered around identifying particle properties that predicted bioaccumulation potential. And some of these discussions were on particle size, hydrodynamic diameters or aggregation state of the materials, dissolution rate and so on as possible triggers. And from some of the analysis that's already been done, there's no single metric that gives a simple explanation as the best predictor. But what we have been able to do with some multiple regression analysis in the background is to show that 2 or 3 metrics give fairly good, strong predictions when considered together. So that might be a way forward. The other aspect that we discussed was looking at attachment efficiency, alpha, given that's an inherent property of the materials, and for various scientific reasons, it may be relatively straightforward to link that to the bioaccumulation issue. It was also noted in the discussions that there was a guidance document, the GD318, that was has some information on measuring alpha, and so there's utility there in that methodology. There was also some thoughts that we could develop a separate hydrophobicity test that was intended to be like KOW, but something that would work for a nanomaterial. So that's a possibility too. And for the metal materials, we also kind of recognize that the log KOW is mainly used for organic chemicals. We don't tend to use that for metals in the current system. And so could the inherent properties of metals like valency or density and so on be used as a predictor of bioaccumulation potential? Because we have noticed that that the metals like cadmium and mercury that we know bioaccumulate, well, when we look at their nano equivalent materials, those also tend to bioaccumulate. So there's something there to look at. Anyway, we had quite a broad discussion about possible chemical triggers, and with some new ideas that we hadn't considered before. So that was a very fruitful discussion on that issue. But what we'd like to do is to come up with a chemical trigger that everyone agrees, and it's reasonably easy to implement for regulation. Can I have the next slide, please? Then we went on to discuss invertebrate testing, and one of the aspects here was trying to avoid going to animal testing with fish, vertebrate animal testing, if we could have a reason for waiving the need to do a TG305 fish bioaccumulation test. So we're thinking about a tiered approach to the testing with respect to animal welfare and minimizing the use of animals, vertebrate animals at least. And so there was a discussion about, could we use data from invertebrate tests to give some context to bioaccumulation potential or the risk of bioaccumulation. And there was a discussion around various invertebrate species. We know that there's a Hyela test, which is a freshwater amphipod that seems to be a good test organism. There's also earthworm tests that give fairly good correlations. So if we plot the bioconcentration factors for nanomaterials in the earthworm test with the biomagnification factors in the dietary TG305 method, we get fairly good correlations. But there was some discussion around regulatory acceptance of using a terrestrial species in an aquatic testing scheme, if you like. So could we find an aquatic equivalent to the earthworm test? Well, yes, there are. There are requirements, sediment tests that use lugworms and so on. We also talked about the possibility of using some other benthic species like a marine mussel or a filter feeding organism where there are sort of bioaccumulation measurements out there. But one thing we did agree on was that given that fish tissues can have different levels of lipids and proteins and so on than invertebrate species, that if we were going to compare data across species, we would need to normalize it for carbon content or more likely lipid content for lipid soluble chemicals. But the consensus was that we ought to look at invertebrate testing if possible, and especially the aquatic options, and but also drive things along and keep in mind that there are invertebrates in a number of sediment tests that we might use. We also thought about other ways of generating data on bioaccumulation potential or evidence, weight of evidence for bioaccumulation potential, and there was general agreement that some of the computation models were too early in their use at the moment for nano. For example, nano-QSARs are in their infancy really, but we could develop that further, and also TK and TD dynamic models, where those could be developed too, but they're not there yet for use in this context. Next slide, please. So that was the session A on bioaccumulation. We covered chemical triggers and alternative invertebrate testing. And then we went on to, in the second session on bioaccumulation, to look at the in vitro fish alternatives to the fish bioaccumulation test. And these discussions centered around a number of things. In Plymouth, we'd been working on a digestibility assay for a few years now that is a quick in-chemical method for measuring the bioaccessible fractions of chemicals, and we've used this for nanomaterials. And the idea is you take the animal feed and you digest it in a simulated gut digestion, and then you get some bioavailable fraction. And these assays have been used for soil ingestion risk in humans and food safety risk in humans as well. And this is a fish version of those assays that's been around for a long time. So there was some agreement that would have utility because it was quick and easy to do, and it gave you a useful answer. But there was also a discussion about expanding the data sets to cover herbivorous fish, because in the TG305 there are a choice of fish species, and if you and most of the data we have is on rainbow trout and other carnivorous fish. So could we do a herbivore like a carp or something else to see how that works as well? So quite a useful discussion on those bioaccessible fraction type assays. Then we went on to discuss fish cell lines, and of course there are various gut cell cultures now emerging for fish. The rainbow trout gill cells, RTGs, have been around a long time, and there are rainbow trout liver cell culture lines and primary cultures available. And there were some concerns around whether a cell culture system was a good model for measuring bioaccumulation, in that it's a single cell layer that's quite simple in the dish. We haven't necessarily got to the complex co-culture models that have been used in mammals, like the Keiko cell co-cultures. But nonetheless, there might be scope there to think about how we would use a cell culture assay to be predictive of bioaccumulation. And it was pointed out as well that in the context of REACH, for example, the onus is around in the supplementary material is demonstrating whether or not the substance crosses biological membranes. And of course, if you could show uptake into a cell culture model, then you could give a yes/no answer to that biological membranes aspect. So there's some merits there for the cell culture. We also talked about gut sac preparations, and this is something that that we've been using in Plymouth for nanomaterials for a number of years now. This method originates in animal physiology, in animal nutrition since the 1950s, and it's been used for chemicals for a good number of years in research activity. And what we're able to do with this gut sac preparation is make different regions of the gut in the lab, and we can measure uptake in real time to get accumulation rates in the gut tissue. And the idea is that if you get uptake in the gut tissue, then that might indicate a potential for accumulation into the animal. And indeed, from the data sets that we have so far from different materials and different projects, there's a really good correlation between the uptake in gut sacs to the in vivo uptake rates in fish. So that's certainly a possibility. We also had a discussion about other fish tests that weren't using adult animals, and of course there's the fish embryo test or fish early life stage tests. Those haven't been used for bioaccumulation measurements per se, but that's certainly something that we ought to look into. We've done some experiments like that, and nanomaterials do tend to stick to the chorion on the fish embryos, but the larval stages are quite sensitive to nanomaterials, and there's no reason why we can't get bioaccumulation measurements in the hatched embryos, for example. So there are a number of possibilities there of moving away from in vivo testing on fish around cell culture or tissue extracts from fish and so on. Next slide, please.
You're 1 minute now, Richard.
Okay, so just to wrap up, where do we go from here? Well, the way forward is fairly straightforward for us. We think we can develop a chemical trigger to replace log-OW for nano, but we're mindful of trying to keep it simple and not having too many protocols to arrive at that measurement or measurements. We also think we can simplify our proposals for the overall scheme by having an invertebrate tester Waive TG305. We can certainly make use of in chemical digestibility, and maybe other in vitro tests are not needed. But we're also wary of the precautionary principle and avoiding things like false negatives, so that we can be safe in the scheme that we're using. And there was a general feeling that could we test a few more ENMs, and in particular the carbon nanomaterials are missing because we don't have measurement methods for them in the tissue. But overall, there's a good prospect of some kind of tiered approach to reduce the burden of work in testing, and also enable the 3 R's and animal welfare to be incorporated into the scheme. And I think that's all I've got to say.